Hi there. Today we're going to be talking about clean architecture, learning to build systems that survive time. My name is Jumbo Vitorano and you're welcome to my YouTube channel. This is going to be a series, of course. This is episode 1, designed to help you move from wherever you are right now, whether beginner or intermediate, into becoming a true pro. Yeah, this is all you need, to get started with clean architecture. And of course, there are a lot of clean architecture, video out there. They are very fantastic. But I doubt that this is gonna, be exceptional, whereby you are going to learn from the basic to the advanced aspect of clean architecture. But before we dive in, if you haven't subscribed to the channel yet, please take a moment to do so. Also click the like button. It helps with reach and really encourage me to create more of this kind of content. And don't forget to turn on the notification bell so you will be the first to know whenever I release a new video. All right, so let's get started. So in this episode we're going to be talking about introduction, what is architecture in real life, the software architecture, talk about a couple pillars of modern architecture, why architecture matters in real world, architectural styles in today's industry, advantages of strong architecture, disadvantages of strong architecture, why beginners should still learn architecture early, why architecture comes before code. Software development is more than writing code that works today. It's about building systems that remain understandable, maintainable, and adaptable for years. So just imagine you write a code, and at the end of the day, after writing the code, it's working. But perhaps now come back a month after, you're not finding it hard to understand. In fact, you want to make some changes now. I can't really, put this change here, or like it can't adapt to a new change. So that kind of code we have written, it really is working, but it is not having a good architecture. So why architecture comes before code? And you must really understand that when we talk about architecture, we are not talking about your code here. We are not talking about the logic you have written. We are talking about the way you have written this code. So, and if your code cannot be understood by you when you come back to it, or the next developer that is coming to pick up your code, then you are not having a good architecture. Your code must be understandable, maintainable, and adaptable for years. Yes, I've worked with some engineers, and the feedback I got from them must have been like, hey JB, I love the way you wrote that code. I love the way you started implementing that code. It was really easy for me to pick it up and get started with the code. So you must write code that is, one, understandable and maintainable by you or the next engineer coming to your team, and it must be adaptable. Challenges every project face. I was talking about you writing a code that work, and if the code works right and is not maintainable or is not adaptable. For example, if there's a new feature, so if there is a new feature request, for example, you have built a logic to collect payments, and after collecting the payments, create an order for that user, and there is now a reason for you to do Slack integration. So if there's a reason for you to do Slack integration, that is a new feature. So because it's a feature on its own, if you have not really written this code well, you don't have a good structure for it, then there will be a problem that becomes a challenge for you. Like there's going to be like a new integration. For example, you are using Paystack for your payment service, and now your customers are saying, oh, they also want Flutterwave because they are used to Flutterwave payment services, and you are not thinking about it that the way I've written this thing, can I easily integrate Flutterwave payment service into it? If you cannot do that easily, then it simply means that you don't have a good architecture. So all these things become a challenge for you not to find yourself in this situation. That is the benefit of this series. What is architecture in real life? So I want you to understand that when we think about architecture, I'm not talking about code here. I'm not talking about the syntax. I'm not talking about, you putting down logic. I'm talking to you about, how your system behaves when things change. So let's think about building. When you build a house, the beauty can change. You can change the color from, perhaps you have it colored white before, you can change it to blue, painted it, any color. You can say, okay, let me to change that color, put some, design pattern on the building. All those things can change with time. In fact, you can, change the furniture inside the house. You can, can do all sorts of things to it. But do you know one thing? The structure of that building never change. The way you have built the building, the way you lay the foundation, the structure never changed. Since the structure never changed, then that is what we talk about, architecture. So before you start the house, before you build the house, you must get like an architect to bring up the architectural design, the structure of the house, and this is what that building is going to remain like till perhaps you want to vandalize the house or you want to rebuild it from scratch. So that is architecture in real life, and the same thing applies to clean architecture. So basically, I just want you to picture it like that. When you talk about architecture, you are not really talking about the code, and you're not talking about the syntax. So it's just like the way your system behaves. When things change, remember that that's the way your system behaves when things change. That is, architecture. Now let's move to software architecture. Software architecture is, the fundamental organization of a system, its components, their relationships, and the guiding principle governing its design and evolution. This was given by Baez and Clements and Kaisman. And when you talk about software architecture, you are talking about fundamental organization of system. Focus on all these, critical words. Organization of systems. So it simply means that, you are combining different features together. Then you are now putting them in the right, structure to make up a single system, to make up a single software. The components of this system and the relationship between them and the guiding principle governing its design and evolution. So that is just what software architecture. Software architecture is just the blueprint of how your software thinks and grow. So just look at it like that. The way you think about the project, the way you started building it, and that is the way you are going to continue building on it, continue putting more layers upon it. Let's break down some stuff here, because when we talk about software architecture, there's some core pillars of this software architecture we're talking about here. So we have 3 core pillars, and what are they? Separation of concerns, coupling, and cohesion. When we talk about separation of concern, every part of your system should handle one responsibility. Yeah, I think on the long run in this series, I'm going to even talk about these core pillars more in depth, because this is like a standalone concept on its own. So I'm going to explain to us separation of concerns. I then will be talking about solid principles and some design patterns. For example, dry, do not repeat yourself, CAPS theorem for database. So we're going to be talking about a lot and a lot more, but just let me give you a general overview about all the core pillars referring to here. So when you talk about separation of concern, it's just a design principle that aims to separate an application into distinct layers or modules, and each of these addressing a specific concern or responsibility. This is going to help us to maintain, just like what I said here. If you look at this, it must be maintainable. When you look at separation of concern, I want you to think about a restaurant. When you get to a restaurant, the first thing you're going to see is like you meet a waiter, and the waiter is going to say, "Oh, what do you need? What do you care for today?" And you're going to tell the waiter what you care for, right? So the waiter is going to take that order and take it to the chef, and the chef is going to prepare the food for you. And do you know one thing? The chef is not concerned about coming to ask you what you want to eat. The function of what to eat is depending on the waiter. So the waiter will take the ordering from you. Okay, what do you need? And we take it to the chef. And do you know one thing? The waiter doesn't really care about how the food is prepared. What the waiter will ensure is like the waiter gets the order and what carry the food back to the customer. And one thing about it is that the waiter never care about the payment. You have to go and meet the manager, and the manager will receive the payment from you. So you can see all these things are being separated to layers, whereby the waiter handle one thing, the chef handles one thing, and the manager also handle the payment. So you can see that we have separation of concerns. So that's just the basic explanation of separation of concerns, whereby each part of the system handles one responsibility. So the next thing is talking about coupling. So coupling is just, it means how tightly two parts of the systems are dependent on each other. So I wanted to look at coupling like you putting your hands together. When you put your hands together, if you exert more force, they are tightly, coupled together. But if you don't exert force on it and you are putting a little space in between it, they'll be loosely coupled. So just think about it like that. And perhaps another way I can think about coupling is like it just refers to the degree of interdependency between software modules or components. It measures how closely connected they are. So just imagine two friends, right? And they are very good friends. So the first one is Patricia and the second one is Sarah. So if Patricia's action directly affects Sarah's work, they are tightly coupled. But if it's otherwise, then they are loosely coupled. So just look at it like that. Patricia, if I do anything, okay, if Patricia does anything, if it affects Sarah's work, then they are tightly coupled. But if it doesn't, they are loosely coupled. And one thing about it is that when you have high coupled system, then we say that system is brittle system. And if you have a low coupled system, we say that it is a flexible system. So loose coupling is desirable in a system, and it makes it easier to change or replace individual components without affecting others. So remember that whenever you are building, whenever you're architecting your software, you want to think about a loose coupled system, because it's going to give you the advantage to easily maintain it on the long run. You can see like the purpose of writing a code that has a good architecture is for maintainability. It's not for anything else. The system is going to work, of course. It's going to work, it's going to serve the purpose. But system, when it comes to any system, no system is sustained without being maintained. So you have to understand that sustainability of any system is dependent on the maintenance you are giving to that system. Even your body, if you are not maintaining your body well, you won't be able to sustain it for a long time. So that is why you see some people developing one ailment or the other, because they are unable to maintain their body the right way. So this thing applies to everything. And if you have a tightly coupled system, you cannot easily maintain it. And anything you cannot maintain, you cannot sustain it. So the last one I'm going to talk about when it comes to the core pillars is cohesion. When we talk about cohesion refers to the degree to which elements within a module work together, and performing a single purpose. So just think about cohesion as I want to think about an example. Okay, imagine Chelsea. Imagine Chelsea club. The players, they work together for a purpose. And what is the purpose? To win a match. You understand? So if the striker, is not doing his own role or performing his own role, perhaps, or the goalkeeper is not performing his own role. So we see that there's going to be a conflicting role the way they perform on the field. So in this regards, like these players, they are going to ensure that they perform their own role, they perform their part for the purpose of winning. And that is what question is talking about. That is, each part of the system is well focused that they perform their function for the purpose of ensuring that the system works perfectly. the system works perfectly. So now when you talk about these three components, you must like ensure that you adhere to them, because separation of concern helps to achieve loose coupling and high cohesion by separating concern into distinct modules. And you can see like this separation of concern is going to enable you to have what, high cohesion and what, a loose coupled system. So there's no way you want to build a system. There's no way you want to build a software architecture without applying these principles. They are dependent on one another. So first of all, that you are going to separate concerns, then you have a high cohesive system, and you have a loose coupled system at the same time. And loose coupling and high cohesion are interrelated. When modules are loosely coupled, they are more likely to be cohesive, and vice versa. So by applying this principle, you can create software systems that are more maintainable. So we go back to the definition. If you apply SOC, which is separation of concern, coupling, and cohesion, you are going to have software that remain understandable, that remain maintainable, and adaptable for years. So the next thing you're going to talk about is why architecture matters. Very simple. We have been talking about maintainability, being able to understand your code, and also your code should be adaptable, should be open for change. It should not be tightly coupled. It should not be rigid. One here is feature velocity. So whenever you have a good architecture, teams with good architecture ship features faster and with fewer bugs. So you'll be able to ship out your code with a faster velocity, with a faster speed. It will take you a lesser period of time to ship out, because you are just adding more layers to what you have already. And most times it's just like going to be carrying an implementation from one point to another without even having to write a lot of code. So the next one is reduce technical debt. Bad architecture forces rewriting, sometimes destroying your entire system. So this one is like one of the issues most developers face when they have a bad architecture. So most times they have to rewrite their application several times. I remember when I was still in college, I built a software for agro business, that is inventory management system. And what I noticed while building that time was like I had to be writing the back end more than 3 times, and I had to rewrite the front end like 2 times, because I didn't sit down and write a good architecture for the project. But along the way I learned my lesson. So most times when you have a bad architecture, you are likely going to have a technical debt. But when you have a good one, then you are going to reduce technical debt. And the next one is team productivities. Whenever you hire a new engineer, they'll be able to pick it up, like faster, and like easily they will know what you are doing. So I told you about some guys I work with some months ago on a project. I started the project, and when those guys were hired, they were telling me, "Oh, JB, I love the way you wrote the code. Like I was able to easily pick it up." And even to today, we were adding some features to the code. And one thing I discovered is that whenever there is a new feature, it is just adaptable to those features, that they can easily extend it. It is open for extension, so they can easily extend it, add more layers to it. So it's not like the tightly coupled, whereby if you want to add any layer on top of it, you'll be having an issue. Then the next one is business alignment. Well-structured system adapt easily and quickly to new business directions. So whenever you have a system that is well structured, like you give it a good architecture, it's going to adapt easily to the business direction. So whatsoever feature they are bringing in is going to adapt easily. And the next one is technology neutral code. So clean architecture ensure you can easily evolve without writing the business logic. So we're going to be talking about something we call contracts on the long run. So, for example, if you, I was saying something about Paystack and Flutterwave. If perhaps you were using Paystack before for your payment service and you want to switch to Flutterwave, so you don't really need to rewrite your business logic. You don't really need to rewrite everything about your system. You just have to extend it. So that is we call solid principle. Of course, I'm going to talk about that later on in this series. Why architecture really matters, and this is why it matters. One, it gives you feature velocity, whereby you can build faster. It reduces technical depths, and it gives you team productivity. Business alignment, technology neutral core. So the next one we're going to be talking about now is architectural style. So 1 year is monoliths, layered architecture, microservices, event-driven architecture, clean architecture, hexagonal architecture, onion architecture. This is not everything. We have a lot of architectural style, but I just brought this out because this are mostly what you are going to be seeing on the long run. These are mostly what you're going to be using, except you have like some core system design that you want to do. For example, you want to write operating system for yourself, or you want to build a system level or low level algorithm for yourself. So that is different. But when it comes to day-to-day software engineering, these are the basic architectural styles you have to know. So monoliths, when you talk about monoliths, it is very common. You starting your application, put the front end, put the join the logic and the UI together, and you ship it out. Layered architecture, you put your code that is it's monolith, but you just put them in layer. Then the next one is microservices, combination of different monoliths. When you talk about different monolith now, you have more than two monoliths, you combine them together, so that is microservices. So the difference between the monolith and the microservices is like the monolith under microservice, one of them perform just a single function. It's not like we put a lot of functions together, a lot of features. No, so it's different. So and the next one is event driven architecture. So this one is actually used also under, perhaps you can use it under clean architecture, you can also use it under microservices. But our focus for this series is clean architecture. So we have clean architecture, we have hexagonal architecture, we also have onion architecture. Of course, they look similar, but clean architecture is different from hexagonal architecture, onion architecture. Because when you talk about onion architecture, just look at onion. Onion has different layers, so that is why it is called onion architecture. They look similar, but the way they are written is a bit different sometimes. In fact, like hexagonal architecture, it has a lot of layers than most times the design pattern we put under clean architecture. So for example, for clean architecture now, we have the presentation layer, we have the infrastructure layer, we have the repository layer, we have the the application layer. So for hexagonal architecture, we have much more than that, whereby we have sub layer inside all these things. So, but of course, for this series, I've said earlier on, the focus is clean architecture. I just want to show us the architectural styles, and I want you to realize something, that these architectural models exist because different systems have different needs. So sometimes all you need is monoliths. Please go with it. You don't need to stress yourself about clean architecture or microservices. So when it comes to MVP, sometimes it could be like clean architecture. All you need is clean architecture. You don't really need microservices. So know what's will help you to ship faster, and on the long run, you can always scale up. So that is my advice for you when it comes to choosing architectural styles. So the next one is advantages of strong architecture. Number one is give you long-term maintainability. I think I've been, talking about this maintainability for so long. So it's going to give you a long-term maintainability, and it is scalable. Scalability is of high level. So architecture supports growth in traffic, users, and complexity. Just imagine, you want to scale your database. If you have a good architecture, it will be very easy for you to scale up, or you know for you to scale up. Yeah. And when there is like increase in the number of users, it's very easy for you to add more resources to your infrastructure, because you know you have taken time to to design the architecture of the system. And the next one is flexible, so you can adopt new tools without a massive rewrite. So just imagine today, myself and my CTO, we were discussing about Slack implementation, and wanted to integrate Slack into the code base. And what I'm talking about here is like, wanted to capture some data and send it to Slack. One thing came up during our conversation is that the way we have written the code, it's also flexible, that we didn't really need to do much. That in a twinkle of of an eye, we're able to get the implementation done. So when you have a good architecture, your system will be flexible. And the next one is high developer productivity. It's going to ensure that there are clear boundaries, and these clear boundaries, they eliminate confusion and bottlenecks. It's not like you don't know what you are doing. You know what you are doing. And what architecture helps you to do is, it helps you to enforce rules. It helps you to enforce regulations. And this is, I said earlier on, like, architecture, software architecture, it is the blueprint for which your system thinks and grow. So that is how you have thought about that system, and that is how that system is going to grow. So it helps you to enforce rules. When I say, whereby any developer that is coming on your team, or any new hire, when they pick it up, is not going to be writing the way he wants or the way she wants, but it's going to write according to the rules and the regulation you have enforced on the code base. And the next one is testability and reliability. So any system that is not reliable, then that system cannot be predictable. So a strong architecture is going to give you a reliable system, and a system that you can easily test and verify its predictability. It is very, very predictable when it comes to a system that has strong architecture. And the next one is business continuity. So we have like a good architecture, life will be so easy for you. Life will be so easy for you. Then what are the advantages? Of course, I will not tell you that because clean architecture is sweet, is interesting, it makes life so easy for you. There are no trade-offs. Yeah, for everything that brings pleasure, there are trade-offs. If you say, I want to be serious with writing code, there are trade-offs for writing code. To be serious with learning tech, the trade-off is like, sometimes you don't have time to watch movies, you don't have time to do what others are doing. You just want to be writing code, fixing bugs. So in life, whenever anything is working well, look at it carefully. There are trade-offs. There are some things that they are sacrificing for you to just work. And one of the things is that higher initial complexity. So beginners struggle with layers, abstraction, and boundaries. Yes, when I started, I didn't really understand the concept very well. So I had to talk with some of my guys, that, okay, look at this, how do we go about this? And thank God, I was able to work with engineers that are very, very, they are very good at clean architecture. So these guys, they explained clean architecture to me that time. Of course, I wasn't able to apply it very well until I started, building for companies. So higher initial complexity, that is what is gonna bring to the team. The next one is slower early development. When you talk about slower early development, So when you want to build small thing or you want to just develop small feature that in monolith is going to just be, you'll be writing small code. But this time around, it's just going to take a lot of time because you have to structure, you have to write different structure, you have to follow the pattern. So it will take a lot of time. So it slow down the development phase. Then the next one is, you're going to have more files and boilerplate. Yes, you have more files and boilerplate. In monolith, you don't really have much files. Everything you just type it. You can even put the whole logic in one file. Of course, I'm not expecting you to be doing that as a developer, putting all your logic in the file. So separate concerns, and that is what I have been preaching so far. But of course, one of the advantages of strong architecture is like you're gonna have more files and boilerplate. And just imagine starting from the presentation layer, that is controller level. You know, you separate all the controllers depending on the number of modules you have. Then from the presentation layer, you go to the application layer. So when you get to the application layer, it might be like you have the contract, you have the service layer itself, and you are going to be writing two files for just a feature. For just a feature, you are writing for two files. So you have more files and boilerplate. So after the application layer, you still go another layer again, infrastructure layer, then you go another layer again, you go to repository layer, then you go another layer again. So it is a lot, right? So you have more files, you have more boilerplate. Sometimes like, what is this? This is tiring. But of course, that is one of the disadvantage of strong architecture. Then another thing, it requires high engineering, high engineering discipline, then high developer productivity. So, yeah, for clean architecture, you just have to be disciplined, because sometimes you may be like, I just want to write this into work. I'm not interested in all this, design pattern. But trust me, it's going to enforce you to be disciplined. And if you are not disciplined, you cannot, cannot write a clean architecture, code. You cannot do it. So you have to be disciplined. Then it gives you, high developer productivity. The another thing is risk of over engineering. So not all projects need complex. I know I told you about it before. Like your MVP really matters here. So sometimes you may require monoliths. So if it is monolith that you want to stick with it, please. You don't need to, to put all energy trying to let the code to look so nice. Let me tell you, customer doesn't pay for, codes that are nice. Customer pays for products that can serve them well. So customer pays for value, not the way you've written the code. So the value, the way you've written the code is of value to you and the other developers that are going to be working on the code. So, but customers that are giving you money, they don't really care about how you have written the code. So please know when to do over engineering and know when not to do it. Another one is greater upfront investment. Yes, so you're going to spend more time sometimes, trying to figure out things will work, trying to connect things. In fact, there's something we're going to talk about in the future, which is dependency injection. That is one of the most critical challenging aspect of clean architecture. In fact, if you are using Java, .NET, C Sharp, that's C Sharp, Next.js, and some other, class-based programming language that supports clean architecture. If you're like, the dependency injection is one of the critical things they face there, because it will just enforce you to do one thing and you'll not be thinking, what am I doing wrong? So greater upfront investments, and of course, I just want to reiterate on the idea of strong architecture. It gives you higher initial complexity, slower, early development, more files and boilerplate, requires high engineering discipline and high developer productivity, risk of over engineering, greater upfront investment. So the next thing is why beginners should still, learn architecture. Yes, you still have to learn it, no matter how, no matter what I have said about the disadvantages, you still just have to learn it. And the reason why you you have to learn it, because when you start, as a beginner, you dump logic inside controllers. Like when I said that time, I'll put the business logic inside the controller. In fact, I will put the the DAL, that is data access layer, in the controller, and I'll be like, did I write something like this? So of course, because I was a beginner at that time, so of course you must recognize early stage, you must recognize the little beginning, of course. And most times, that time I'll write a tightly coupled code, that whenever I want to make any change, I have to write the entire code from scratch. So another thing is mixing concerns. Like, I didn't separate concerns, and I can tell you most beginners will also fall victim of this. So, and why should you learn it? And it is very simple. The why you should learn it early is because when you learn it early, it will enable you to build systems that don't collapse under growth. Then another thing is, it's going to help you to write predictable and testable code, and it's going to avoid you writing an entire app after a year. So and also one thing that you have to know is, like, whenever you're writing clean architecture code, it's going to enable you to think like a senior engineer. So one thing you must understand is that you want to write your code in a well structured way, that whenever you want to make any change, it is easy to to make those changes. And whenever you want to put any feature or add any features to it, it's very easy to extend the features you have before. So that is just the introductory aspect of this series, and I hope you have learned a lot. If not a lot, you have learned one or two. Of course, in the upcoming tutorial, which is part of this series, we are going to be talking about clean architecture, some patterns, design patterns, the do not repeat yourself, a solid principle. As I said earlier on, going to be talking about some design patterns. In fact, we are going to be writing code. We are going to be building project together. So and trust me, this project, I'm going to write the project. I'm going to code along with you guys. The way I write enterprise application, and I'm going to tell you the reason why I am making such decision while even writing code during the coding session, right? So I'm going to tell you the reason why all this and why I'm taking this decision. So of course, I believe that this is going to be an interesting series that you will enjoy. At this point, I think I'm going to say we have come to the end of today's episode. Thank you for watching to the end.